Hello guys, welcome to my video. In this video, we will talk about the week 3 problem set, which is Tideman. Actually, many of us, including me, have suffered in this problem because this problem actually needs a deeper understanding of the algorithm. So in this video, I will definitely try to help you guys to solve this problem in different approaches. Now we will see how to implement this program. Understanding of Tideman election. So at first we will talk how this program works. Suppose an election, in an election, voters are given ballot and they are told to rank their candidate according to their wish. Now we will see an example of ranked choice voting. Here are 9 ballots where 9 voters have given their votes as ranks. We have an array of candidates and we know array's index basically starts with 0. The 0th index of candidates array stores the first candidate vote. In this case, 0 refers to Alice and 1 refers to Bob, 2 refers to Charlie. We will check each of the ballot and fill up the preference array. So we will declare a two-dimensional array which is called preference, and max here is the maximum number of candidates which CS50 has defined as 9. Preference ij represents the number of voters who prefer candidate I over candidate J. Okay, so now we will check each of the ballot and fill up the preference array. So if we check the first ballot, here the first rank is Alice, the second rank is Charlie, and the third rank is Bob. So from the name of this election, we know it's called ranked pair election. So we know the competition is actually between the candidates of a pair. So if we compare Alice and Charlie, in the first ballot, who wins? Obviously Alice is winning over Charlie. So Alice is our candidate 0, Charlie is our candidate 1. So look at the preference here. 0 is over 2. So 0, here preference is a two-dimensional array, I have told you. So 0 is over 2. So this value should increment. As you see, this is 1 because one voter prefers Alice over Charlie. Now let's talk about Alice and Bob. Who wins? Obviously Alice. Alice wins over Bob. So 0 over 1. 0 over 1. 0 over 1. Okay. So it is incremented by 1. And Alice wins over Charlie and Bob both. But Charlie wins only over Bob. So who wins? Between 1 and 2, 2 wins. So 2 over 1, 0 will be incremented. Okay, we will go to the next ballot. The next ballot is also the same. So these 3 values should be incremented by 1 again. The first of all this, and the second this, and thirdly this value should be incremented because these two ballot is the same. In the third ballot, we are seeing Bob in the first place, Charlie in the second place, and Alice in the second place, and Charlie in the third place. So Bob is clearly winning against Alice and Charlie. So 1 is winning over 0 and 2. So 1 here is winning over 0. This value will increment, and 2, this value will also increment. Okay, 1 and 1. And let's talk about the second and third rank, Alice and Charlie. Alice wins over Charlie, so 0 wins over 2. 0 and 2, this value will increment. 3. Okay, this ballot is almost the same. Actually, these two ballots is absolutely same, so we can just skip this. Okay, the next ballot is not the same, it is different from the previous one, and we can see Charlie is ahead of Alice and Bob. So 2 is over 0 and 1. 2 is over 0, so this value will increment by 1, and this value will also increase by 1. Sorry, this value, because 2 over 1. Uh, the next two ballots are the same, so we can just skip, and let's see what happens here. Sorry, and the last ballot is different, so we will count that. Charlie over Bob and Alice, so 2 over 0 and 1. 2 over 0 and 1, so 2 over 0, first of all, 2 over 1, it will be 6, and 2 over 0, that means it will be 4. 4, sorry. Okay, so let's move on into our next slide. So here you are seeing a graph. Before preparing a graph, we will see how to add pair and how to sort the pair, and then we will create a graph using our log pair function. Okay, so I have the preference table, preference array stored in the memory, and now we will add our pair. And let's see, we have three pairs in this case: AB, AC, and BC. So every pair has a winner, has a loser, and I will also store the margin of the victory and also have the difference between the margins. To add the pairs, I have defined a data type called pair, and this pair has two type of data. One is winner and the second is loser. So we will go through every pair and store the winner one in this winner integer and the loser one in the loser integer. Now start with the first one, 0 1 and 1 0. That means Alice and Bob. So let's see who wins here. Preference 0 1. If preference 0 1 is greater than preference 1 0, then 0 is the winner. Here 0 is the winner and 1 is the loser. Here is 0 1 and this is the 1 0 cell. Okay, so here is 0 is the winner, so 5 is the maximum number of votes Alice have over Bob, and 0 is the winner, and we will add in the table here. Okay, let's move into the second one, which is A and C. That means 0 2 and 2 0. Okay, so who is the winner here? 5. The maximum number of votes is 5, so 5 has 0, that means Alice is the winner here. Okay, so I will add this also in the table, and let's move into the third one, that is that is 2 1 and 1 2. So who is the winner? Obviously 2, because preference 2 1 is greater than preference 1 2. Okay, so 6 is the winner. Sorry, 6 is the maximum number of votes and 2 is the winner. That means Charlie is the winner between Bob and Charlie. Okay, then C is the winner. The margin of the victory is 6-3 and the difference is 3, and this 2 has a difference of 1. Okay, now we will sort the pair. Sort the pair in the decreasing margin of the victory. We have to sort pair in the decreasing order of the strength of victory. That means the maximum difference will be at the top and the minimum difference will be at the bottom. So 3 is the maximum difference here, and Charlie is the winner and Bob is the loser here. So I will just put it at the top. So this needs no sorting because 1 1 is equal, so I can just put this here. Okay, so the next one is log graph, or you can say log pair function. What the log pair function actually does, we have to log pair from the first one at till the last one if there is not a cycle. If the pair creates a cycle, then we have to skip it. We don't have to lock it. So how actually we should log the graph? Okay, so let's see the first one, that is 3 difference between C and B. C is the winner, so we have to mark an array from C to B. So that means we have logged C over B. Okay, so the next one is A and B, and A is the winner here. So actually it doesn't create a cycle here. So actually what is cycle? Suppose you're starting from C, and in this path you are going to B from C, and then B to A, and then from A to again C. So your starting point and your final point is the same, so that will create a cycle and you should avoid it. If it creates a cycle, you should not lock it. Okay, so the next one is A and B. So A is the winner, it doesn't create a cycle, so you should just lock it. Sorry, A is the winner. From A to B the arrow will indicate. Okay, let's move on to the next one, A and C. Okay, so A is the winner and C is the loser. Now just think about A and C. If I mark an arrow from A to C, does it create a cycle? No, so we can lock it. Now we have seen how to lock a pair. Next, move on to the next slide. Okay, so there is a question here, what will we do if a pair creates a cycle? We have the sorted pairs here. Sorted here is the sorted pair is different because in the previous one we A is locked over B and A is locked over C, but here B is locked over A, so it will create a cycle actually, because let's see here, C to B, B to A, and then A to C. So the final initial point and the final point is identical, so it will create a cycle and we will see how to avoid it. Okay, so the first one C to B, the second one B to A, the third one is A to C. Oh, that is creating a cycle now, so we should avoid the pair that creates a cycle. From the sorting order we have this first and we have this in the second, but we have this in the third. so we should not lock it. Okay, we should not lock it, and in this case the function print winner will work in that way. The candidate who has no arrow pointing at him, or we can also say the candidate who is the source of the graph, should be declared the winner. Okay, so in the program we will now talk about some lock array. So in the program we will use a two-dimensional boolean array named named lock to implement our idea. So here is locked I and j, and if locked ij is true, then there should be an arrow from I to j, and here locked to 1 is true. That's why a arrow is pointing from C to B. Okay, so here there should be an arrow pointing to jth candidate from the ith candidate. In this case, locked to 1 is true, and locked Bob is referred by 1 and Alice is referred by 0. So locked 1 0 is true, but we have seen that we cannot lock A to C. That means we cannot log 0 2. So log 0 2 is false. We are in VS Code, and this is the code CS50 has provided you. So let's see this code. So see here, there is max, and this is a constant defined by CS50. The maximum number of candidates is defined 9. Okay, so max is equals to 9, and it is a constant, so it cannot be changed afterwards. Okay, so here is a preferences array. So that is a two-dimensional array I have told you earlier. So here is the locked array, boolean array. This is also a two-dimensional array, and this is the details over the works of preference and locked. Okay, so yes, there is a pair data type, and that is string candidates max. Okay, so this is the pairs candidate which will go through this pair data type. Okay, so there is 6 functions, and you have to complete these 6 functions to complete this code, and so that it works perfectly. Okay, so both function, record preferences, add pairs, sort pairs, lock pairs, and print winner. Check for invalid uses. If argc is less than 2, that means if you are only writing /Tideman, that it will show you the use. Okay, and if there is an invalid uses, then it will show you the use and return 1 and terminate the program. Populate the array of candidates. Okay, so the candidate count is equals to argc minus 1, because the first argb0 is actually /Tideman, so you have to decrement it by 1 and put it into the candidate count. Okay, so if the candidate count is greater than max, so you have to print maximum number of candidates is 9, that is max. Okay, so here is a for loop, and you have to put the argbi plus 1 is equals to candidate I. So what is that actually? So you have to write the names of candidates in this terminal window, and this from this terminal window you have to put the candidate names into candidates array. So this is for this for loop is doing this. Okay, so clear graph of locked in pairs. So initially we have to uh, make the locked ij function, locked ij data to false. We have to set locked ij data to false, because we have to lock the graph using this locked array. So initially we have to put all of the values to false. Pair count is equals to 0. Okay, so firstly the voter count, you have to input the voter count here, and for each of the voters and each of the ranks you have to call the vote function once. Okay, so rank I is voters I preference and integer rank candidate count. Okay, so let's get to the vote function. So you have to check if there is a name which is the input of the voters. So you have to check the name and update the ranks also. If the vote function returns false, then you have to print invalid vote. Okay, if not, then the vote function will update the ranks function. Okay, so now let's see what we have to do here in the vote function. Okay, to check if there is a invalid candidate in the voters preference, so first of all we have to go through every candidate of the candidates array. So I have to use a for loop for int I is equals to 0 and I less than candidate count, and then I plus plus. So I have to use a function that is called strcmp. It means string compare. So for this reason I have to include a header file which is include string.h. Okay, so if str compare means we have to compare the name and the candidate's I, so if the string if the name and candidates I is equals to 0 equals to 0, then we have to update ranks. If that is false, we have to return false. Okay, so if strcmp its name and হচ্ছে candidates I, so a string compare returns 0 if these two strings are identical. Then we have to update the ranks array. So the input, when the boot function is called, the input was j and the j is equals to ranks. So the voter is in his jth rank and the input j is stored in a variable called rank. Okay, is equals to I and return true. Okay, then we have to check this all the candidates. If any candidate name is identical with name, then we have to return true. If after completing this for loop, if there is no identical name in the candidates array, then we should return false. Okay, so if we write here else return false, then it will return false in the first run of this loop. So we don't want this, right? So we have completed the both function. Okay, so update preferences. So I have given an example how the preferences actually works. Okay, ranks. So we have to uh, input the ranks array in the record preference and it will record the preferences in the preferences array. So here rank preference, 0 is the first preference and 1 is the second preference in both function. So ranks I represents the user's ith reference. So I have updated rank which is equals to 0 and which is user's ith preference. Okay, should return true. Okay, both function has been done. Now let's see the record preference function. The function is called once for each voters and takes as argument the ranks array. Recall that ranks I is the voter's ith preference, where ranks 0 is the first preference. The function should update the global preferences array to add the current voter's preference. Recall that preference ij should represent the number of voters who prefer candidate I over candidate j. You may assume that every voter will rank each of the candidates. Okay. So you are saying that record preferences is in a for loop. So for every voter, it is called once. Submitting all of the ranks of a voter. Okay. So now let's see how this record preference will work. Okay. So we have to see this slide again. So let's see for the first ballot. Alice is rank 0, Charlie is rank 1 and Bob is rank 2. Okay. So as we see, preferences is a two-dimensional array. So we have to make two for loops, and the first for loop starts with 0 and ends less than candidate count, and the second for loop integer j starts from I plus 1 and j is less than candidate count. So why this happens actually? Because let's say in the first ballot, which is Alice is rank 0. Okay, so rank 0. So rank 0 is preferred over rank 1 and rank 2. Okay, so preferences rank I, rank j should be plus equals to 1, and that should be incremented by 1. Let's see. So here's a rank 0. Rank 0 means Alice, right? Rank 0 means Alice. Rank 0 means this 0, and rank 1 is actually candidate 0, candidate 2, that means 0 and 2. Preference 0 and 2 should be 1, and then rank 0 and rank that is rank 2 should be 1. So actually, preference rank 0 is Alice and preference rank 2, that is Bob, okay, should be incremented by 1, because rank 2 is equals to actually 1, because it is Bob and Bob is referred by 1. So we move into our tideman.c program and make two for loops. I less than candidate count and I plus plus, then a nested for loop for int j is equals to j starts from I plus 1, j also less than candidate count and j plus plus. So then I should update the preferences array. Preferences ranks I, that means the ith rank of the voter is winning over the jth ranked voter. So this should be incremented by 1, and then we should return. This is a void function, so actually it doesn't return anything. So what I have written here actually, so I have started from ranks I to all the way to ranks j, and think about a situation where the I is equals to 0. So ranks I represents the first candidate that a voter has voted. The first voter actually wins over all of the candidates below him, right? So that's why I have written I plus 1. So when I is equals to 0, j is equals to I plus 1 to the candidate count minus 1. So the first ranked candidate is winning over all of the candidates, and that's why I am updating the preferences by this. And the second, when I is equals to 1, that means the second ranked voter is winning over the third ranked voter. That means j is gonna be 2. When I is gonna 1, j will be 2. Okay, so I have actually made a mistake. So this bracket should be here, because the star CMP starts with a bracket and ends with a bracket, and it will return 0 if that two strings is identical. Okay, record preferences is done. Now we have to add pairs. To add the pairs, we have to run the same loop we used in record preferences. So I'll just copy it and just pasting here. So the difference here, that we have preferences ij is declared, okay, before in the previous function. Before that I am declaring two variables, integer a and integer b. Okay, so I am uh, putting preferences ij into a. Actually, to make it much easier, we are declaring two variables a and b, nothing else. Preferences j and I is b. So what actually happens with if preferences ij is greater than preferences ji? I have told you earlier in the slide then that if preferences ij is greater than preferences ji, or a is greater than b, then I will the ith candidate is winning over the jth candidate. So let me write the code here. If a is greater than b, then the pair count is a global variable which is primarily set to 0, and we have to increment the value by 1 after adding one pair. We have to increment the value by 1. Okay, so pairs, that is our array. Sorry, pairs is our array. So pair count, the first one is 0, and the index of the first index of array is also 0. Dot winner is equals to I, because I wins over j. So sorry, and the loser here is j. Okay, we have to use another if else if statement. Else if b is greater than a, then we have to use the opposite logic here. Winner is j, and the loser is I. Okay, and after using this, we have to increment the value of pair count. Pair count plus equals to 1. Copy, and I'm pasting here. Okay, done. So the add pair function is done. Okay, what I have done here, I will go through each of the preferences here, and if I wins over j, I will add the pair add them in the pairs array as winner and as loser, and b is greater than a, I am doing the same and increasing pair count variable by 1. Okay, add pairs is done. Now sort pair. Sort pairs in decreasing order by strength of victory. Okay, so let's read the description of the sort pair function. The function should sort the pairs array in decreasing orders of order of strength of victory, where strength of victory is defined to be the number of voters who prefer the preferred candidate. If multiple pairs have the same strength of victory, you may assume that the order does not matter. Okay, so for this, uh, before completing the sort pair function, I want to introduce uh, you with the selection sort in Python. Okay, so in this sorting system, we have an array which is called diff. So, so first of all, we have to go through every element or every number of this array, and then primarily I have defined a as the diff I, that means the first element. Okay, so max is equals to a. I have assumed that the max element of this array is a, and I have declared another, I have used another loop here which starts from the from I plus 1 if the first I is 0, and that will start from 1. Okay, so b is equals to diff j, that means if I is equals to diff 0, then b is equals to is the next one. Okay, so if b is greater than max, that means if b is greater than a actually, the which is the maximum element I have assumed, then max is equals to b, and I should also store the index. After going through every element from the I plus 1th element and from the last element, if we have found an element which is greater than max, we should store it in the max, and the index should be j. And then suppose I have found here the 7 is maximum. Okay, so I should swap the 7 here and the 5 in here. So a is index. I have found here 0 1 2 3 4, so index is equals to 4. So diff 4 is equals to 5 because a is this, and the 5 will go here, and the maximum value will go at the first place in the place of 5. Okay, so diff 0 is equals to max, that means 7, and that's how this program will work. And I will just copy and paste the whole thing here. So firstly I will declare a variable called int n is equals to 0 and initialize n to 0. Then I will make an array a size of pair count, integer array pair count. Then for a for loop, int I is equals to 0, I less than candidate count, I plus plus. Then again a nested for loop for int j. J starts from I plus 1 and j less than candidate count j plus plus. Okay, now I will again declare here diff. So now I can declare integer a and b. I need this diff a and b variables in my code. So a is equals to preferences ij, as I have written earlier in this code, a and b, and I will use a and b to compare the differences between the preferences. B is equals to preferences j and I. Then there is a conditional statement. If a is greater than b, then execute this. Execute, I will store the a minus b into diff variable a minus b, and p of n, that means in the first run, that is p of 0, is equals to diff, and n is incremented by 1. Then else if b is greater than a, then execute the code below. I will store the difference of b minus a into diff, and p of n is equals to diff, and then n plus equals to 1. I am storing the difference of the preferences into difference variable, and also storing the differences in the p array. Okay, now I will get out of this loop, and then I will make integer max and integer index again to for loop. Firstly, for int I is equals to 0, I less than candidate count I plus plus. In this for loop, I will store p of I, the ith element of p, into a, and the maximum value. Firstly, I assume that the maximum value of the array is the first element, that means a. I am declaring some variables which should be handy for us: winner 1, loser 1, then winner 2, loser 2, and winner final and loser final. These variables will help us in this code, so we will see how to use them. So the winner 1, as I have initialized the max value as the first element of this p array, and I will also store the first winner into winner 1 pairs I dot winner, and the loser 1 is also pairs I dot loser, and winner final. And suppose a is equivalent to winner 1 and loser 1, and the max is equivalent to winner f and loser f. So winner f is equals to winner 1 and loser f is equals to loser 1. Then again a for loop for int j is equals to I plus 1, j less than candidate count, and j plus plus. Now in this for loop, I will store the jth element of p into the b variable. Then the winner 2 is the pairs jth winner, and the loser 2 is the pairs jth loser. Then there is a conditional if, as I said in the sorting in Python, if any of the element is greater than max, then I should store the b or this element, the maximum element, into the max variable, and in this case I will also store the winner and loser variable in the winner final or loser final variable. Okay, so b, if b is greater than max, then I will do just max equals to b, index is equals to j. I'll also store the index. This is very important. So winner final is equals to win2, and loser final is equals to lose2. And then I will go out of this for loop, and I will execute a conditional, and this conditional is actually for shortening some steps. If a is not equals to max, then the store in the p index is equals to a. I'm just substituting the values of p index, that means the maximum, and the first element, that is pi or a, and the pi is equals to max. And with this I will also substitute the value of winner and loser. Pairs index dot winner is equals to win1, and pairs I dot winner is equals to winner final. Pairs index dot loser is equals to loser1, and pairs I dot loser is equals to loser final. Okay, so I'm done with that. And then in the final statement of this function, I will return. The next function is log pair. To be honest, the different variable is unnecessary here. We can directly store the difference here. So I will just remove the difference here. This is unnecessary, right? So I am deleting this thing. Okay, now it looks good. I have done some slight mistakes. So in the 180 number line, I should have declared the variable integer j, and also here integer j. So many mistakes, sorry for that. 183. Okay, I Okay, there is no problem here. So now we will see how to implement log pair function. For this, we have to iterate all over the pairs and check if any of those pair does create a cycle or not. If a pair creates a cycle, we should not lock it and rather skip the pair. If it doesn't, then we must lock the pair. So firstly, I will declare two variables called winner and loser. So we will write a for loop, starts from 0 and I less than pair count. Okay, I'm writing this. Int I is equals to 0, I less than pair count, and then the increment, sorry, I plus plus. The winner variable actually stores the value of the ith pair's winner, and the loser is the ith pair's loser. So pair, it's i's dot winner, and the losers takes the value of the ith loser dot loser. So after that, uh, I will use a function called cycle that will actually check if locking this pair will create a cycle or not. Okay, so actually cycle will return false if the pair doesn't create a cycle, and we have to lock the pair. Okay, wait a minute. Cycle it is true, or you can actually put this like that. You can actually write here true. There is no problem. So actually, if you want to use true or false, you have to include a library named stdlib. Include stdlib.h. So actually I have to use false here. If this is false, if cycle returns false, then we have to log the pair. Locked winner loser is equals to true. Okay, so else that actually skips the process here, and again it starts, it will increment and check this statement if I less than pair count, and we'll do this the same thing again and again. Okay, so I will create a new function named cycle that will actually a boolean function cycle, and it will take two input values. One is winner and the other is loser. Okay, so I will put this thing at the top as the prototype of this function. Okay, now we will see how to implement this cycle function, and I will do this in two ways. The first one I will use recursion. You know, the recursive function is the function that calls itself until it hits the base case. And the second one, in the second one, I will use the while loop. Actually, it will be much longer, but if you actually understand the whole thing, it will be very clear to you. So firstly I will use the recursion, and I will write the base case here. If the winner and loser uh, pair are already locked, sorry, if the loser and winner pair are already locked, then we will return true. That means uh, if the loser if the loser in the pair wins over the winner. Okay, so if it's true, then we will return true. If it doesn't return true, that means else. Else we will go in a for loop. Int I is equals to 0, I less than candidate count. We'll go through all the candidates and then I plus plus. Okay, so now we will check if uh, this creates a cycle or not. If locked loser I locked loser I and cycle winner I. Okay, so what this line actually do is it will check if this locked loser I is equals to true and the cycle winner I is equals to true. So let's see one thing. If the main loser that I am getting input here, the winner and loser, if the loser wins against the ith candidate, the locked loser I is true, that means that the loser is winning over the ith candidate, and cycle winner I is equals to true. That means the ith candidate is also winning over the winner. So loser is winning against I and I is winning against winner. So that will eventually create a cycle. So for this reason, if this statement is actually true, we will return true. We will return true. If after executing this for loop, this function does not return true, then we should return false by default. Actually, sorry for doing some slight mistakes here. I have written pair instead of pairs, so I am okay. So let's move on to the next function, which is print winner. So I have checked with check50 that if these functions are working properly or not, and this is the result. We have been doing pretty good until the print winner function, and we will actually execute this function also now. Okay, so I will complete the cycle function using while loop in the last of the video, because it will take a lot of time to understand and to execute the program. Actually, using while loop in this cycle function is a bit of hard and time consuming, so I have put this clip in the end of the video after finishing the print winner. Okay, so hope you will see the function. Okay, so now I will declare a variable called n. Then I will have to iterate uh, all of the locked pairs. So for this I will write two for loops, nested for loops actually, for int n is I is equals to 0, I less than candidate count, shit, count, and then I plus plus. Here I will initialize the value of n to 0, and then I will write another for loop, int j is equals to 0, j less than candidate count, also candidate count, j plus plus, sorry I have done a mistake here, less than j plus plus. So then there is a logic here. If locked j I is true, then n plus is equals to 1. Okay, so After executing this for loop, I will check if n is equals to 0 or not. If n is equals to 0, then I am printing print f %s \n and the value of the winner candidates I. Okay, and then I will return. So what have I actually done? I set a variable called n, and in the first for loop, when I is equals to 0, I have initialized it to 0. If locked ji is true, then increase the value of n by 1. And after executing this for loop, if the value of n remains 0, that means the ith candidate hasn't lost against anyone. That means there is no arrow pointing at the ith candidate. So actually he is the source of the graph, and from the specification of Tideman we came to know that who is the source of the graph uh, is the winner. So if n is equals to 0, so I hasn't lost against any of the candidates, so I will have to print the candidate i's name as the winner and return the function. So that's I think end of Tideman, and I actually promised you that I will write a cycle function using while loop, and now I will do that. Before that, I will have to check if my the entire code is correct or not by using check 50. We will now see how to implement the function using while loop. So to do this, we have to change the cycle function only. We don't need to change the log pair function, because if the cycle return false, we have to log the pair, and else we should skip the pair. So how we should implement this? So firstly, I will declare three variables called n, and initialize the variables n is equals to 0 and p is equals to 0. So I will also declare an array of size pair count, pair count. Okay, so I will store the first element of this array uh, to loser. Loser will be the first element of this array. So how should I write this? Array 0, the 0th index of the array contains the loser. So then we will enter the while loop n less than candidate count. Okay, so now we will see a presentation of how this cycle works, and I will complete this while loop a bit later. Okay, let's see what actually the cycle function does. So the cycle function actually takes two inputs, that the first one is winner and the second one is loser, two integer inputs. And suppose we have a pair, the winner is C and the loser is G. So the winner and loser is fixed, and then the first element of the array, of the end array, is also fixed, and that is the loser. The array of 0 is G, it is fixed. Okay, so we have declared this. So we will keep the track of our path in this array. Okay, so next we will go through every branch and check if the branch contains the winner or not. If the branch contains the winner, then it will create a cycle and we should not lock it. We show the cycle function should return false actually. So the first one is GA. So here in this GA pair, G is the winner and A is the loser. So if this creates cycle or not, sorry, so if that pair is locked or not, it is locked because it is locked end n is true. So p is equals to p plus 1, that means p is equals to 1 from 0, and the one element of this array will be a. Okay, so then what we have to do is move next in this path, and we have found if AF pair is locked, and that's why we have to increase p by 1, and the p will be 2, and we will store the loser in this int array. So if will be here, and now we will have to check if this path creates a cycle or not. So as we can see, there is no candidates in front of if, or we can say there is no path after if, so we have to go backwards. So what is the logic here? Locked end in, the end is actually if, and the n is actually the number of the candidates. That means the candidate number starts from 0 all the way to the candidate count minus 1. That means iterating over all the candidates and checking if candidate is winning against the other candidate or not. So it is false and the n is candidate count minus 1. So we have to go back. How we can go back now? We have to um, decrease the value of p by 1. So the p is actually 1 now. Then we have to go back again because um, there is no candidate except if that a is winning against. So we have to go back to g now. So the p is actually 0 now. After a, g is winning against b. So locked in n is equals to true, and now we will increase p by 1. So now p is equals to 1, and we have to change the value of array 1 to b. Okay, now b will be the end, and b is winning over e, and this pair is locked actually, and that's why we can go through this path. And again we can go forward and increase the value of p by 1 and change the array 2, that means array p to e. We have to go forward again, and now e is winning over f. So we'll increase the value of p again. The value of will is 3 now, and array of 3 is f. So can we move further? No, the answer is no. We cannot move further because there is no path here. So we have to go backward, and that's the logic as I said previously. So locked end n is equals to false and n is equals to candidate count minus 1. So we have to go backward and decrease the value of p by 1. Okay, again the same logic. E is not winning against any candidate except f. So we have to go backward again and decrease the value of p, and now we have found a candidate d. B is winning over d and the pair is locked. So locked n is equals to true. We have to increase the value of p by 1 and put d here because the value of p is 2 and array p is equals to d. We have to assign the value here. Okay, then we have to move forward and boom, we have found c here. So it is creating a cycle because the winner is c and actually the pair starts from c and ends with c. So this pair is creating a cycle, and that's why the cycle function should return true. So how we should implement this? Locked int n is equals to true, and we should increase the p by 1 and put c here, and now we have to check it. If int is equals to winner, return true. Okay, so if this int we have assigned the value of array p into int, so the array p, array 3 is c, and c is equals to winner. That means c is equals to c, and that is true. So it will return true. So the one thing I have uh, written here, the arrowed pair refers to locked pair. Okay, so for the first couple of pairs, or for the first 3 or 4 or 5 pairs, there will be no locked pair. There might be no locked pair to create cycle, so this pair can be locked without checking actually. So this example is for understanding a complex situation. Okay, so I have talked about the lock function previously. If cycle function returns true, then locking the pair will create cycle, so we shouldn't lock it, and else we should lock it. Okay, in this loop we have to iterate over all the candidates. Okay, the n is referring to the number of candidates, and using n we can get access to the candidates array. So let's see how we should implement this thing. So firstly, int is equals to array of p, then there is a conditional here. If locked int and n, so initially starts from 0, and n will hit candidate count minus 1. Okay, so if locked n is equals to true, have we written std bool here? No, actually in VS Code we can use true or false. That means we can use boolean value, but in code blocks or other IDE we cannot do this, so we can just left here. That means if locked int n becomes true, it will go through the lines that I will write here. P plus equals to 1, p will be incremented by 1, n is equals to n. So we must have to keep track of the n. Then array p equals to n, and if n is equals to winner, then we will have to return true. If n is equals to winner, we should return true, and if it doesn't, we will have to set the value of n into minus 1. I will actually explain the reason of assigning minus 1 to n. So after that we will write else, and then if n plus 1 equals to candidate count and end is not is equals to loser, Okay, so uh, here is the logic. If n plus 1 is equals to candidate count, that means we have iterated over all the candidates and the end is not equals to loser. The end is not equals to loser. So the end is not is equals to g according to our example. Then what should we do? Then we have to uh, make we have to initialize uh, n from array of p, and p minus is equals to 1, and we have to decrement the value of p by 1, and after that, after the else, we have to increase the value of n by 1 and that's why I have assigned the value of n into minus 1, because here is the value is minus 1, and after that in this line the value will be 0. So that's why it will start from candidate 0, um, and it will iterate over all of the candidates and check if that will create a cycle or not, and that's why I have assigned minus 1 to n. So after that we have to write a conditional. If n is equals to candidate count and end is equals to loser. Okay, so what is this actually? N is equals to candidate count. Okay, so I have iterated over all the candidate 0 to candidate n minus 1, and after incrementing this value from n minus 1 plus 1, that means n will become n will become candidate count. So this will the first conditional will be true, and if the end is equals to loser, and if the end is equals to loser, that means if there is no cycle. Okay, if there is okay, so n is equals to candidate count and the end is equals to loser, that means okay, just think about a situation where this is not creating a cycle, and after iterating all over the candidates, after hitting F here, and this there is no path forward, so we have to move backward. So we have to move backward, and after hitting G we have to check this logic we have written. If end is equals to loser and n is equals to candidate count, we should return false, because after iterating all over the branches, all over the candidates, we still haven't found any cycle. We still haven't found C. We still haven't found the winner of the function losing to D. So we should return false. So if this condition is true, then we should return false. And actually we should always return something from a function, and actually notice here, if this logic is true, then we have to return true. If it isn't, it will execute this line and return false. For safety, we should return false here. So that's the case here, and we have to make Tideman, and luckily there is no mistake, and I have to check it by using the check 50, so it will take some time. Okay, so here is the result, and all of the functions are working properly, and that's the end of the video. Thanks for watching this video. Please like and comment in this video and subscribe to my channel.